in this story, we have a bookstore application, which is an e-commerce style application. It's a Node.js app, and this is running on Azure VMs, and they are containers running inside of the VM. Now, this is following a very similar pattern, except it's not on EKS. It's not a Kubernetes cluster. It's a VM that's running a container, and they have managed identity to access different things, right? To access the container image, to access Azure storage, all of that stuff, right? So they have those parameters set. Now here, we have an application that is vulnerable to server-side template injection. So the idea here is you compromise the application, you gain access to the backend container. Through the container, you escalate privileges to the underlying operating system, steal the credentials. Then actually, you don't even need to steal the credentials, since the container has access to pushing to the Azure Container Registry. We are just Trojanizing the image and pushing to the Azure Container Registry. That's what we're really doing. Now, the detection sequence is something that we're doing a little differently from before. One is we're using KQL with Microsoft Sentinel to be able to identify the shell. So in this case, we're going to set up a reverse TCP shell. And since we're going to set up a reverse TCP shell, we have a KQL query on Microsoft Sentinel that should be able to detect that shell. This also gets delayed a little bit. Microsoft KQL analyzes the log workspace, and it takes about 6 to 15 minute kind of a delay for you to be able to detect it, which is why you'll see that the same kind of 15-minute delay that you saw with guard duty, you'll also see here. Defender for Cloud automatically has some container scanning enabled, and you can, of course, use other queries with the log analytics workspace.